All right. Well, in order to address the question of how malware avoids detection, we need to think about the different ways that it can be detected. One of the ways that we can detect malware is by looking at network traffic. So naturally, when you talk about trying to avoid that detection, well, one of the ways that you can avoid that detection is um, well, I guess, okay, so one of the ways you can detect some of this malware is if you have network traffic going to a known command and control server, then you might look just at the DNS records to see, okay, is it going to evil.cnc.com or something like that? If the DNS service is going to a known malware command and control server, then, well, you're infected. So one of the things that can be done to get around this from the malware perspective is they use what's called a domain generation algorithm, or DGA. So the domain generation algorithm basically says here is a list of several different domain names that the command and control server will be found at. Except it's not really a list; it's an algorithm to create that list. And this would have to be in combination with some sort of dynamic DNS, where they can easily change their domain, easily change their name. So these usually consist of a random assortment of alphanumeric characters. So if you see lots of random assortments of alphanumeric characters showing up in your DNS, no, that's a pretty good signal that there's some sort of domain, some sort of CNC going on. And or if you see lots of NX domain errors, again, this would be because it's basically just going through, here's a list of a bunch of different possible domain names. It's just going to go through those until it finds the actual the place that they're currently being hosted at. But you can still potentially recognize bad IP addresses, IP blocks, or something like that that are taken, that are generally used to host these command and control servers. And I mean, I guess you could use like a VPN or something like that. But again, well, you don't really want your command and control server to be changing, or you want it to be changing in a predictable way, because you need these infected machines to be able to reach back to get to the command and control server. So you might do something like a fast flux network, which this is one way you can continually change your IP address. Yeah. Another thing that can be done is changing your DNS traffic. Instead of it being over the normal port 53, figuring out some alternate way to channel that DNS traffic, just to make it so that just to make it so it's less visible. Let's see. Also, as far as command and control traffic can be concerned, there's actually known instances where people have been putting command and control signals up on blockchains. So like on Bitcoin blockchain, they send a certain amount from this address to this other address. And if your computer sees that particular transaction having taken place, then it is taken to be this particular signal. So it's really kind of trying to hide that. I mean, it's kind of hard to spot because the number of different ways that they can hide this. Or they can just put up something on social media, put up some random assortment of characters that means to attack this particular address. Or, yeah. Actually, I think the cryptocurrency blockchain, the specific example that I'm thinking of, that one was not the actual control. That was to reestablish the command and control server. So the original command and control server was taken down, but they had something put in place where the cryptocurrency, where the specific blockchain held the essentially instructions to find the next command and control server. Yeah, your imagination is the only limit for some of these things. I apologize if you can hear my cat meowing again and again. He's hungry. Let's see. Of course, you can use for avoiding network traffic or network being noticed over the network. It's very common to use ports for non-standard uses. So sending encrypted whatever traffic over port 443 wouldn't really be noticed because, hey, it's encrypted. Everything is expected to be encrypted over 443. You can't really see what it is. But yeah, it's a good way to hide. This is, you can kind of call this covert channels. You might conduct the, I think I already talked about the command and control over, no, this is a little bit different. So this isn't reaching out to the command and control server over DNS. This is actually conducting the command and control over DNS. So some way that this might be accomplished is by uploading a particular TXT record to your DNS server. And when somebody checks the DNS, they get that TXT record, and you can get your command and control stuff through that. Yeah. Let's see. Another example of a covert channel here is exfiltrating data over ICMP. So you don't normally think, oftentimes when you're thinking of checking your traffic, you're thinking of checking what's over TCP or what's over UDP. But ICMP, this is the protocol that's used for like pings. That's another protocol that can be used to send information. And if you put a little ping packet with a bunch of data on it, this is a good way to exfiltrate data and just, it's difficult to detect. Although if you happen to know to look for it and you see, oh, there's lots of traffic happening over ICMP, that can be a red flag in and of itself. What many of these network-based malware scanners, they have trouble detecting things if you might break it up. If you break up your packets into very small bits, they might, because if they're signature based, they're looking for a particular string, and if you break that string that they're looking for up amongst several different smaller packets, not getting to the maximum possible packet size, just intentionally sending small packets so that you're not sending large enough chunks for your network-based anti-malware to see anything. Yeah, that's another thing that can be done. And of course, sending slowly, or maybe this is probably more relevant to if you're trying to exfiltrate data, or if you're if somebody's trying to enumerate your network, just doing things slowly. It sets off all sorts of red flags if you see a flood of somebody does a ping sweep over the course of 1 second. They do a ping sweep of 256 addresses, and then they start scanning all 65,000 ports on a couple of whatever things are up. That'll send up all sorts of flags from any sort of intrusion detection device. But if they do it slowly, and they only send one ping every second, and then they start taking, slowly checking the various ports, this can be harder to detect. Depending on your software, you might still be able to detect that, but it's all about trying to hide with the good traffic, hide amongst the noise. Let's see. So that's talking about ways of detecting malware at the network layer. You can actually, of course, on the individual end systems, you might be able to detect malware at execution. One of the ways that Windows does this is with AMSI. That's the particular service. I don't know. I guess the particular, I don't know what you would call that. In any case, AMSI stands for anti-malware scan interface. Like if you put script into PowerShell and it is known bad, then PowerShell will say, hey, this has been stopped from being executed. This particular scan is signature based, and it'll basically take what you type into PowerShell, and it'll see if it matches a known signature for whatever, and it'll just stop its execution. Yeah. So like if you have somebody trying to run Mimikatz, that's one example where you end up having to or yeah, it gets blocked. So naturally, the next thing you know, this is very much a cat and mouse game. You can start looking for various bypass methods that have taken place. I actually have a link here, Pentest Laboratories, and let's see if I can pull it up really quick. There we go. This actually has a bunch of different methods of evasion that can be used to allow the execution of malware. My animals, I apologize. That's my dog squeaking at her toy. So there are, let's see, when you go to execute something in say PowerShell, I think this is just PowerShell actually. When you go to execute something in PowerShell, it does scan the buffer, it scans strings. Again, just looking for signs of malware. And so there are various different ways that the various different evasion techniques trying to downgrade the PowerShell session to version 2. I'm not sure what version it is normally, but if you put PowerShell to version 2 and then you try to invoke Mimikatz, you can see it just runs just fine. If you're not familiar with Mimikatz, I probably should have pointed this out in the malware section, but Mimikatz is used to retrieve typically hashes of logins. So it can be used to enable like a pass the hash attack. So that's basically a replay attack. If somebody was logged in, you can basically send that information again and pretend it's you logging in. Or if you have the hash of their password, you can do an offline dictionary attack to try to figure out how to crack that hash. In any case, let's see. Base 64 encoding. This is a very common technique. So here they have an example. Let's see if I can make that a little bigger. So if they try to invoke Mimikatz here, you can see it is prevented from being blocked by your antivirus software. That's the AMSI. So instead, what they do is they have this little string right here. You can notice base 64. You can recognize base 64 because it's all going to be uppercase, lowercase, alphabet. There are numbers in there, and there's a few limited punctuation. Equal signs are common punctuation you'll see in base 64. And I think there is there's a little bit more punctuation, but it's primarily uppercase, lowercase letters, and numbers. Will give you base, or that's what you'll see, and that's how you can recognize that something is in base 64. If you're interested in trying to figure out how to, I guess I'm jumping the gun on this. I'll talk about base 64 a little bit more. It's a little bit later in my notes. Let's see, hooking. This is an example, or in this example, this is this is replacing the DLL, or putting a fake DLL, and when you execute PowerShell, it'll run that DLL for the AMSI hook. You can actually do memory patching, which is kind of messing around with the specific memory of Windows memory. So let's see, there is, that one's a bit more in depth. Forcing an error. Certain errors can allow a bypass here. I'm obviously not getting into any details. If you're interested in reading through the specific details, you can go to this web address. I will put it in the links. Registry key modification. There's a bunch of different ways. DLL hijacking. I think that might actually be the one I was talking about before. Oh no, this one is. I don't know. In any case, you get the point. There are several different techniques that are used for bypassing this AMSI. Let's see, another way, another thing you need to look for evasion, detection avoidance, I guess is what I'm calling it here, is trying to figure out how to avoid detection, before, not when the file is being run, but when it's just being stored. One of the ways that this can be done is by just not storing it, so-called fileless malware. So this is just running the executable directly without having it being ever written to your hard drive or into your mass storage. Um, One of the things about this, though, is this particular malware wouldn't exist between boots, or wouldn't persist between boots, because it's just in memory. It's not it is volatile, I guess I should say. So usually when you're talking about fileless malware, there has to be some aspect of the malware that gets written in order for it to persist between boots. I mean, it doesn't always have to. There is some malware that only exists until you restart your computer, and then it's gone. That's not common. Most malware does try to stick around, but it can just be fileless entirely. Of course, to find that, you might be able to find it in Task Manager, just seeing what kind of processes are running. Or if you need to get more into, kind of analyzing the specific memory, you might use something, tools like FTK or Encase. This is getting more into digital forensics. Definitely not so much an incidence response. As far as actually hiding files on your file system, on your Windows file system, let's see. It's not that uncommon to just go ahead and put your files into folders that aren't really looked at by the user very often, such as System32 or roaming data. I don't know about you, but it's been a while. I don't typically look at app roaming data when I'm on a computer. You can also exploit the alternate data streams that is a feature of NTFS file systems. That's nice and redundant. So alternate data streams, if you were to do something like, I don't have my example prepared here, but if you were to do, if you were to output, so type just takes characters and outputs them. So if I was to do type notepad.exe, that would just take all the characters from this particular file and it would output them. And of course, this nice signal, this greater than thing here will redirect it into calc.exe colon notepad.exe. This will actually take and make it so that particular file is, it's not visible when you do your normal dir, when you try to show things. Yeah, actually, I will show this example. All right, so here we go. Let me go ahead and clear the screen here, whatever. So what I did here in this particular directory, you'll notice I have calc.exe and notepad.exe. At least that's what's visible. If I was to do this type notepad.exe and redirect it to calc.exe on notepad.exe, and I do a dir, you can see it's not visible. Even if I was to try to show hidden folders, so dir/ah, this would show only hidden files and folders. You can see it doesn't show up there. It's not hidden. That's not what's happening here. If I was to do dir/q to see the owners of the files, kind of what I'm doing here, it's not going to show that. However, if I did dir/R, this actually does show alternate data streams, and you can see only now does that extra file actually show up. You can see it exists right there. It has some extra data associated with it, and then you could access the file that way. But it's trying to. These are just different ways that these can be hidden. I guess you can. If you hide stuff in the Slack space on your drive, there's, like I said, just different ways of hiding these. In general, using encryption and decryption, or encryption or encoding, I should say. I already talked a little bit about base64. One nice tool for converting base64 is called CyberChef. So if I open up a browser here and just search for CyberChef, this one at GitHub is the one that's typically referred to when people say CyberChef. If I was to take some, well, this does all sorts of conversions. I can, for instance, convert something to base64 by saying, hello, this is in base64. You can see it actually converts everything to base64 down here. If I wanted to go back the other way, I can get rid of that particular thing and say from base64 and it converts it from base 64, and it actually has the nice thing when you highlight up here, it'll show you what's highlighted down there as well. So base 64, like I said, is a very popular way. It's a very easy way to hide information, to kind of encode it. Another thing that's typically used is URL encoding. This is especially if you're sending things over the internet. URL encoding means, well, in general, URL encoding, you might be familiar with encoding spaces, for instance. You might see %20 for doing spaces. But those aren't the only characters that can be encoded. Commas, you can see I'm encoding the comma here. It looks like that's %2c. Decimal points, that would be %2e. So if you had malware.exe, it's not going to match your pattern if you're looking for a specific a period in your network traffic or whatever. It's not going to match this exactly because that's not the character that shows up here. And you can also do things like if you're talking about cross-site scripting or something like that, you might have your opening and closing brackets. I don't know why it didn't do that second one. Weird. Yeah, I don't know why it didn't do that. Opening angle bracket there, what it looks like is %3c. Closing angle bracket is %3e, and so on. I don't have these particular things memorized, but if you go to CyberChef, obviously you can see this can do a lot of this translation for you. It's a pretty handy tool. Let's see, the next thing, changing capitalization. Since a lot of these signatures are, it seems kind of silly, but changing the capitalization does change the signature because it's using different characters. But the thing about PowerShell and Windows in general, it's not case sensitive. So if I was to type in something.iex, if I was to do, let's open up PowerShell here. If I was to do IEX, invoke expression, that's what IEX stands for, and then malware like this would have a different signature than if I did capital IEX malware. So you'll see occasionally people just throwing in different capitalizations so that things look different. Also, when you're talking about PowerShell, I believe, completely ignores backticks. Backtick is the character to the left of the 1 on your keyboard. So you might do something like, I guess in Windows, d backtick IR, and you can see it interprets that as dir, showing just the directory. It's the same as if I was to just do this without the backtick in there, and I could have additional backticks. And this is all to get just different signatures. Oh, okay, it doesn't like that. Okay, well, maybe it's not quite as tolerant as I thought. Maybe it's if there's multiples. I'm not sure exactly what is breaking that. But in any case, backticks, I've seen those being used to change the signature as well. Yeah, I don't know what the rules are there. Let's see. Obfuscating code is very common. This is especially used to prevent any sort of static analysis. So obfuscating code means taking and having, oftentimes this is going to be having multiple different layers of malware. So you have one layer that is the, essentially it's just there to unencrypt or decode the inner layers. And you'll have several different layers of that, of various obfuscated code before you can actually get to the actual code, the actual things that's bad for your computer that you want your antivirus to detect. I linked to a John Hammond video that goes through breaking through some of this obfuscation. I think it's worth your while kind of seeing how that works. Although, again, when we're talking about analyzing malware, that's a little bit beyond the scope of you as an incident responder. Although it's good to know how it's done, because sometimes being able to do a little bit of that is pretty helpful. So IEX is used for invoke expression. And so what you'll often see is taking, saying IEX the unbase 64 or the base 64 decoded of this string. So one of the things that Windows looks out for, the AMSI looks out for, is looking for when is this IE invoke expression called. So you might do something like, just for obfuscating that, you might say, take the 5th character of C:\Windows. That's the I. You might take the E, say that E from system.exe. So C:\Windows, whatever. Or some other, the X from some other exe file. So in doing this, you can say, take this string and take the whatever, the 5th character from this string. And again, the AMSI isn't going to have it's not going to have very much luck in trying to realize that, oh, you're trying to invoke expression on this particular, this malware. Let's see. Specialized malware. Okay, I already talked about coming in stages. One of the things about it coming in stages means that malware tends to be fairly easy to assemble various components. In fact, several of the common like pen testing tools, whether you're talking about Cobalt Strike or I can't remember what it's called. Various, whatever, the pen testing tools, PowerShell Empire, yeah, I can't remember, whatever. If you're talking about these various tools, they often have capabilities to create malware, and you might pack that malware up, and you might take the one particular dropper and put it with a different payload. You basically custom making your own malware off of these various other components. And again, when you put it all together, it becomes more difficult to recognize via just the signature. When you're talking about more advanced persistent threats, so this is getting beyond. This is getting a bit beyond malware at this point, and talking about more like if you have somebody actively on your network, techniques that are used to evade detection. Living off the land is definitely a technique. This is basically using, I guess you can say, not importing anything to the system, so not uploading any software, any specific malware, just using the tools that are already available on the system. And very common tools are, well, PowerShell. It's a very powerful tool. If you're on a Linux system, similarly Bash. Using RDP is definitely a living off the land thing. If you have somebody trying to get access to your computer, then if you have RDP set up on it, they have access to your computer potentially. PSExec is another example of something. This allows this is part of the sysinternals package. And sysinternals, it's a very common admin tool, very common administration, but actually it's sometimes flagged by some antivirus software as a rat, because it essentially is. It allows you to get remote access to various console applications. And so if you have that on your system because you have a legitimate use for it, you're going to use it for administration. But some hacker starts using it against you. Well, it's being used against you. They have remote access. Even something as simple as Netcat can when we're talking about this living off the land, basically, like I said, it's using whatever's already there. Let's see.